Assalamualaikum, and I hope that you guys stay safe. For this session, I'm going to continue where we left last week. Previously, I have introduced you guys to a different type of data analysis. There are three types. There is the descriptive analysis, there is the inferential, and there is the exploratory. But before that, before we go further deeper into type of analysis, I would like to introduce you guys to the data itself. I have introduced you guys to different type of data analysis. There are inferential, there are descriptive, and there are the exploratory data analysis. And for today, I'm going to introduce you guys to two topics. The first one is type of data, and then the dimensionality of data. Remember, every time when you do your experiment in your study, you collect a sample from the population, okay? And then you do your experimentation, or you do a survey, you record your information, and your information, the information that you collected coming from your essays, from your experimentation or from the survey, can be divided into two groups, okay? The quantitative and the qualitative data. I guess the quantitative is quite self-explanatory, while for the qualitative data is any form of data that you guys don't get the direct numbers. And for example, like in the survey, you asking opinions based on the verbal communication, or is it in a form of filling the form in a scale of 0 to 1. Those are considered as a qualitative data. When we're dealing with the qualitative data, we always put them in the categories, okay, into many, one or two or several categories. Besides calling the qualitative data, we also call this data categorical data. We can further expand categorical data into three different types. The binary, by all means, you have only two types, or you only collected two types of data, for example, like gender, male and female, or any form of data, you're asking for the feedback, whether it is good, yes, and you don't like it, you just say no. As long as this data only involves two variables, it's considered as involve two categories, it's considered as a binary data. Any data that have more than two categories, for example, like you're recording data that asking for ethnicities, where you look at from Malaysia itself, we have the Malays, the Chinese, the Indian, we have the IBA, and we have the Orang Asli. So it involves so many categories. And then you're not just looking at the ethnicity, but you're also looking at another one example is the blood type. We have the AO, BO, AA, and all of this. So those data that have more than two categories is considered as a nominal data. Another one is the ordinal data. In the data that collected were arranged in order. For example, like you're asking the feedback. The most common one is you're asking for the feedback, whether how do you think about this particular subjects in the ESPP? So if the survey always asks from 1, 2, 3, 4, 5, and you guys put the 5 is the most satisfied, okay? And then we have the degree of pain. If you are, for example, have you guys went to the clinic, they tend to quite common ask you between 0 to 10, how do you describe your pain? You say 10, which is very, very severe, or 2 or 3, 5, like bearable. Okay, so these are the things. This kind of information is considered as the ordinal data. Okay, that being categorized under categorical. While for the quantitative, if you guys remember, there is the two types of data in quantitative data. The first one is if you count values, for example, individual, you count the entities. Those are a discrete. You're asking for the discrete numbers. All right, the information, for example, number of cells in your skin per square centimeters. Okay, those are considered as a discrete data where there is no decimal point at the back. All right, While we have the continuous data, with the continuous data, for example, is you're recording the height of the particular person or population and the weight or the assay, the values that coming out from the qPCR assay. Okay, those are considered as a continuous data. Once you have all your data, you put together in a table. And the whole reason is for you to do some sort of analysis, whether it is a statistical or it can be any graphical. So this data that you collected coming from different experiments or different assays, as long as you merge them together into a table or into a different form of, for example, like data tree, as long as it is answering your objective, one particular objective, and also considered by computer as one unit can be recognized by the computer for you to do so the computer can do any form of statistical analysis, for example, and these are considered a data set. Okay, when we talk about data set, it have different type of categories, and they have not just that, it also involve the dimension. All right. When we talk about dimension, same as when you draw a graph, that is a one-dimensional graph, two-dimensional pictures, or three-dimensional animation, for example. Okay, same goes with data. Data have their own dimension as well. You can categorize into three types of dimension. The first one is univariate, bivariate, and multivariate. Okay, so what is meant by univariate? Univariate is you have your data, you only measure one particular condition or one particular subject. Okay, you only measure one variable. Okay, for example, like you are studying, you're only recording the blood pressure in the frog population, in your local area. So what looks like when once you record them, you put on the Excel, you tend to put in the form of a list. For example, in this instance, you have one column, you just record the blood pressure of the frogs, for example. Okay, and sometimes you can even put in the form of one row, and that's it. Okay, sometimes you put a title at the end here, or you put a title at the top. Okay, this kind of data is considered as a univariate data. So we have another one, the bivariate. The bivariate is you measure two variables in the per subject or in your per condition. So for example, like in this instance, we measure the previous for the univariate data, you only measure the blood pressure, but in this instance you expand, you include the weight of the frog as well. Okay, now you have the blood pressure data, and then you have the data on the weight that are coming from the same experiment or some observation. These are considered as a bivariate data. Okay, because they are related to each other. For example, they relate to being one individual. Okay, so for example, in this instance, in these particular cases, we have the untreated and the treated. These are the same example I took from the previous lectures on the power calculation. Okay, remember we have the several replicates, replicate 1, replicate 2, replicate 3, okay, and then measure for example, these are the morphology, okay. This is an example of bivariate data. You tend to arrange them in the form of column, or you could arrange them in the form of two rows, okay. And you have row untreated, and these are the value, and then you have your treated A, and then these are the values. These are the things that you guys usually arrange in your spreadsheet. And common format that you usually store them in the form of table. I guess you guys pretty much guess what it meant by multivariate. Okay, so by all means, multivariate, I just want to repeat, just want to tell you guys, the definition is you measure on many variables, for example, per subject or per condition. Or it can be like many conditions, okay? Not just a per condition, it's also based on many condition. Okay, as long as answering the particular objective and can be recognized by the computer as a unit, then it is considered as a multivariate data. Again, in this instance, we studies on the blood pressure, cholesterol, weight, blood type in a local frog population. Even you're not just studying, you can also include the species of the fraud as well. Now you have different type of species, and there are so many variables. Those are considered as a multivariate data. I think I need to make the correction here. It has to be doesn't always to be per condition. It can be many conditions. All right. So what it looks like, these are the most simplest one. Usually you record the data in the form of tables with many plurals or column. In the system, we have the untreated, we have the replication, treated with A, and then these are the values, then with the replicate, with the 4 replicates, and treated with B, and then C, and D, and so on, so on, so on. Sometimes you could also do the dose response curve, which these are the with untreated, and you have this different a series of different concentration, and you have your replication. Okay, now you have a multivariate data based on different concentration. Okay, then to form in the system, we tend to record in a form of table. Sometimes for those who deal with data science, this kind of data can be sorted in a form of data tree and matrices and many ways to store the data. It is important. Why do we need to know our type of data? Why do we need to know the dimension of our data? Can we just do the analysis straight away? Right? There is a caveat. If you are not knowing the type of data you collected, the dimension of your data. The reason is you need to know the type of your data, the dimension of your data is you want to make sure that when you do the analysis, you want to do the analysis accurately and represent your data appropriately. Okay, so by knowing the dimension of your data, the type of data that you've collected, you have the ability to identify the appropriate numerical data analysis. For the example, for the EDA, the expert data analysis, there are different type of analysis or tools that you could use to understand the character of your data. Same cases for the descriptive analysis. If you want to know what kind of, whether you need to use the median or the mean, or whether what kind of the appropriate representation for your data. And then for the inferential, when we talk about inferential, we talk about the statistical tools that we're going to use, what kind of type of tools that we need to know, whether it's a parametric, whether it's a non-parametric data. Okay, by knowing the type of data that you collected, you guys could choose the appropriate statistical analysis for your data. And the whole reason is you guys are able to reduce the probability for you to commit the type 1 or the type 2 errors. This depends on especially the type 1 errors, the possibility of committing the possibility for you to accuse someone guilty while they are not. Okay, we don't want to find any false positive data. This can be by choosing the wrong statistical tools. All right, and also when you summarize your data in a form of graph, by knowing the type of your data and dimension, you guys could choose the right appropriate graph to represent your data accurately. I know it's quite common for you guys just use the bar graph. Okay, I could tell you bar graph is more than adequate. Dot plot is everything. Okay, you guys need to know that these bar graph and dot plot are not the best in any type of data that you have collected. Okay, and it is important for you guys to know that the bar graph is not and dot plot are not one size fits all body size. Okay, it's not the best fit. So there are different type of data. So there are certain type of there are different data, different graph that are appropriate for a particular type of data. We're going to discuss more in our following lectures. Okay, in summary, data can be categorized into two major groups. Okay, the data that you collected in your experiments, qualitative and quantitative data. Okay, so I think it's time you need to be aware of when you do your experiments for your final year project. You need to know what kind of data you're going to collect. Okay, and it is common even in very small research. For example, in a very small study, for example, in your study, your final year project, for your dissertation, you're going to collect different type of data, going to have different several dimensions. Okay, and it is important that as long as the data that you collected can be recognized by the computer as a unit or answering one particular objective, those data that are collected are known as a data set. It is important for you guys to know the type of data that you have, the dimension of your data set, so that you know you could choose the right tools for your statistical analysis and also for your graphical summary. Okay, what kind of graph that you need to use. Okay, I think that's it for today, and thank you very much.